day, everyone, and welcome to this episode of the Industrial Innovators Podcast. I'm your host, Don Cooper, and today I'm excited because we're going to be talking about MachOne technology from Soundwave Inspection Systems. MachOne is the fastest leak and blockage detection system for heat exchangers and boilers. And today I'm going to be speaking with Ivan Rakic. He's the COO and he heads up the R&D team with Soundwave. Ivan, welcome.
Hi, Don. It's great to be here with you today. Thank you for inviting me to discuss about our latest innovation, the MachOne.
I've been excited to have this conversation for a long time. You and I have been colleagues in communication and for several years. And now MachOne is ready to share with the world.
It sure is.
So before we dive into the tech a little bit, tell me who Soundwave Inspection Systems is and the team involved, and then tell us about MachOne. What is MachOne?
Yeah, sure. So Soundwave Inspection Systems is a Dutch company with headquarters in Roosendaal, Netherlands, and R&D and analysis center in Belgrade, Serbia. Soundwave Inspection Systems is specialized in manufacturing and developing advanced NDT solutions based on acoustics. Our latest product and our latest innovation is called MachOne, and as you said, that's the fastest tube inspection tool for heat exchangers and boilers in the world. The unique feature of MachOne that differentiates it among all other existing traditional technologies, it's speed, which is only 3 seconds per tube. That's several orders of magnitude faster than anything else currently used in the industry. MachOne has a capability of inspecting tubes as long as 40 meters or 130 feet when inspected from one side, or 80 meters or 260 feet when inspected from both sides. It covers whole range of heat exchanger and boiler tubes, starting from 7 millimeters in inner diameter up to 76 millimeters in inner diameter, which is up to 3-inch tubes. Unique ability of MachOne is that it's capable of inspecting all kind of materials, all kind of shapes, including U-tubes with the coverage of a U-bend area, thin fans, twisted tubes, straight tubes, any kind of tubes. Materials that we can do are basically all that exist, including even plastics or graphite materials. Every kind of metal is supported as well, because the MachOne doesn't use physical probes as traditional technologies do. Instead, we are using sound waves, to be more precise, acoustic pulses, to test tubes by pushing those acoustic pulses down the tube and recording reflections. Those reflections can be created either by obstacles such as blockages or other defects like holes or even wall losses. Then our proprietary algorithms are used to determine exact location, type, and size of detected defect. So that's all being done in 3 seconds. After that, analysis takes place, and we guarantee reports within 24 hours, with real-time analysis also possible, and preliminary reports within every hour. So that positions us as a fastest tool for tube inspection in industry.
We've got a lot to unpack there. I don't know if there's much I can do in 3 seconds. When literally nothing can get done in 3 seconds, and inspecting a tube in 3 seconds seems miraculous to me. All the other technologies that clients are likely using today to inspect tubes, take orders of magnitude longer. Some of them are really, really long processes, but if you're talking about 3 tubes a second, how many tubes are you going to get done in an hour, in a day?
So in 24 hours, realistically speaking, because it's human beings that are using our technologies, so we need to make some breaks, right? So realistically speaking, anything from 12,000 tubes up to 15,000 tubes per day is possible with a single MachOne device. And every hour, realistically speaking, it's around 800 tubes per hour. I mean, that's a huge. As you said, it's orders of magnitude faster than anything else. We were speaking about minutes, sometimes even hours per tube with traditional technologies.
So, I don't even know. I mean, there's so much to unpack. That's the speed side of it, the material side of it. I mean, every other technology out there, is either ferro or non-ferric, materials. They all have limitations on the kinds of shapes. There's lots of types of tube configurations that other electromagnetic technologies just can't inspect. They can't get around. You mentioned U-bends. There's a lot there. So, thinking about MachOne, you say MachOne, I say MachOne. It's the European, North American potato sort of pronunciation, I think. But dive in a little bit to what are some of the challenges that MachOne can solve for clients, the listeners?
Well, as you said, there is a lot left to unpack. So let's start with things that other technologies simply cannot do. Blockage detection inside the tubes, that's something that no other technology can detect. There is a simple reason for that, and that's the fact that they are using physical probes. So just if you imagine the physical probe traversing the tube, when it reaches a point where the blockage is, that probe simply cannot go through, right?
Right.
So the conclusion from that kind of inspection is that tube is blocked. We don't know where the blockage exactly is, how big is that blockage. Maybe the tube is fully blocked, maybe is only 50% blocked. We don't know. With our solution, now we are able to do that as well. Another thing, this is closely related to blockages. The issue that not only inspection crews are facing, but also mechanical teams, is cleaning. So you have to determine how clean tubes are before you start inspecting with traditional technologies. To take as an example, Iris. Iris requires perfectly clean tubes. So if you have even slightly dirty tubes, Iris probe cannot pick anything. So that inspection time is wasted. So it's very useless to do a quick scan of the whole bundle with our tool before proceeding with any traditional technologies if needed. Another major thing that we cover and other technologies struggle with is a leak detection. So I'm proud to say that we are the best and the fastest tool for a leak detection inside heat exchanger and boilers. We can detect holes, true wall holes, starting from 0.5 millimeter in size. Anything else cannot compare to that because certain limitations apply for our different technologies. For as an example, Iris has a very limited capability of detecting leaks whatsoever. Eddy current, on the other hand, has a limitation of about 1.5 millimeter or so. But then we have to include the previous thing that I said, that's a blockage detection in combination with leak detection. So if you have a blockage which is preventing a physical probe, eddy current probe, of traveling across the tube, and you have a hole after that blockage, that hole will simply be missed and cannot be detected. With our tool, we can detect multiple defects, even combination of those defects, one after another. So blockage doesn't mean we cannot detect anything after that blockage. It's exactly opposite. Only in the case of a fully blocked tube, we cannot, but in any other case, we can detect leak even after blockage.
Okay, more to unpack.
Yeah.
So, when clients are normally, using the existing methods, probes can't get past 20 and 30% fouling and blockages, and their reports come back saying tube blocked. They can't see anything beyond that if there's other fouling and other blockages or other defects. the customers are normally then putting those on a tube plug list to plug the tube off, not knowing what's what. So what you're saying is, just from a blockage standpoint, not only can you detect the blockages, but you can give the customer some indication of the percentage of blockage.
Exactly. So we give exact percentage of inner cross section blockage. Okay. Starting from only 2%. That's the reason why we are able to use our tool as a cleanliness assessment, because we can detect blockages starting from 2% of inner cross section blockage, okay, which is unheard of.
Right. We'll get to cleanliness in a second, because I think that's another whole use case that I think I want to dive into. So you can detect up to a 2% blockage. So if a customer, with everyone else, if there's a 5, 10, 15, 20% blockage, the probe can't get by. They've still got 80, 85% flow through that tube, and their process engineers are now having to plug that tube off and lose heat exchanger efficiency. Not only can you detect if it's 5 or 10%, but you can also detect if there are other blockages, so that they can get better assessment on whether they should or shouldn't block it or plug the tubes. And you can also see if there are holes or leaks beyond those blockages, if there are some percentage blocked beyond. Obviously, I'm going to assume you can't see past 100% blockage.
That's true.
Right. But if it's 80% blockage, your sound waves are still moving past that and seeing beyond to the rest of the tube, and being able to give an evaluation of the rest of the tube that other technologies can't do.
Exactly.
Right. So you're able to help them, understand what's going on in the tube, and even make decisions around choosing not to plug tubes that other technologies are forcing them to make a call about plugging or not plugging. That's incredible. Cleanliness. So you were talking about Iris, and we know that Iris is a technology that is super precise, super slow, not really good at finding leaks, but really good at measuring wall thickness. But back at the wash bay, when the mechanical side of the turnaround are having to clean these bundles for Iris, that is often a place where the people managing the wash bay and the bundle cleaning process are often either, it's a time-consuming process to go back and forth between them and the Iris contractor, or they've got to dedicate someone at the wash bay who's part of the tube inspection team to do some assessments on whether it's clean enough for them to do the work. What can you do? Like, how is MachOne helping with that cleanliness assessment to speed things up, to evaluate what's really going on in the tube, and to, move things along faster for decision making, to go from washing to inspecting when the client wants to use Iris technology, or when they're simply getting it clean for any of the other technologies?
Yeah, there are a couple of things we can do to help our clients with our MachOne here. The first thing, the sheer speed of MachOne is something that's allowing us to inspect a whole tube sheet in less than an hour or a couple of hours, depending on the tube sheet size. So that makes it possible to quickly scan if the cleaning that's been done before is enough for another crew to proceed with Iris inspection. Or what else we can do, we can pinpoint the tubes which are clean enough for Iris inspection. Since Iris is so slow, it's always being used as a sampling tool. So rarely or never the whole tube sheet is covered by Iris. So we can pinpoint which tubes are clean enough for Iris inspection, so they can proceed with that. We can provide additional information, such as if there is any leak in the whole bundle, since we already screened it for cleanliness and we have that information already. So we're adding a couple of values here, so we can help out the Iris crew or any other traditional method screw. And we can add additional value here by showing where potential leak is, or where blockage is. So maybe a mechanical crew can go back and concentrate on those tubes to clean those tubes that are dirty enough so Iris cannot be used. So it's cleaned again.
Right. So speed up the process, help them decide which tubes are ready for Iris, being able to be that that evaluator that can help the wash contractor and the wash coordinator know if they've gotten them clean enough to be able to hand them off. I mean, I've seen lots of back and forth and a lot of delays on critical path on the cleaning and the inspection crews. And as you say, Iris is a very slow process. It's many minutes per tube and they are often, hey, the tube is not clean enough, send it back to the wash bay. Kinds of activities that are going on that can cause a lot of frustration between the reliability inspection department and the mechanical department that's required for the cleaning. This can be a game changer just in that one use case, just in cleanliness assessments, to be able to keep things moving. And because what are the alternatives? Like, what are people normally doing for cleanliness inspection or cleanliness evaluation when without this?
Honestly, I have no idea. Maybe they can try a videoscopy and boroscope and try to visually confirm, but that's also a painfully slow process. So something as quick as this simply doesn't exist.
Cross comparing different technologies, you're talking about leaks. Iris is really poor at finding leaks. Eddy current can, but it's got limitations in what the sizing of leaks to 1.5 millimeters and larger. Kind of just like speed, you just said that you can find leaks that are 3 times smaller than what eddy current can find.
Not only that. Yep. Not only that.
What else?
Yeah. Eddy current has issues with materials. You cannot use eddy current for every material in existence, especially on carbon steel tubes, which make majority of tubes in the industry. So you simply have a limitation that you cannot avoid, which is a material.
Right. So you've got material issues. So now you've got a plate. A lot customers are trying to find hot spots, and they're trying, so that they can, plug, decide where they're going to have the plug tubes for reliability. Customers are trying to find leaks for reliability. In terms of tube maintenance, sometimes they're, beyond that, they're looking to evaluate the bundle in terms of, its trend of life for if it needs to be retubed. But a lot of the work that's getting done on a turnaround is looking for fouling that create and pluggage and blockages that are going to create hotspots for tube failure in operation or leaks, and you can find both.
Yeah.
There's other things that these tools need to do in terms of wall thickness and whatnot, but so much of what's trying to get accomplished with the tube cleaning is about finding leaks and about finding fouling. And the speed of this is just incredible, and the sizing of the holes that you're finding is wild. But I'm kind of pivoting a little bit now to beyond heat exchanger tubes. What about boiler tubes? What about furnace tubes? Those things have lots of oddball geometries, bends and turns. What can you do for customers there? Because furnaces and boilers, they're looking for leaks.
That's correct. The shape of the tube isn't an issue for our tool. You stepped away from heat exchangers. I would like to go back briefly to heat exchangers to explain why. Since we can successfully inspect U tubes, including covering U area, which is very challenging, by the way, for traditional technologies. There is almost no efficient way of testing U area of U bundles. And we are covering that as well, and successfully finding leaks and blockages and wall losses as well in that area. Now to go back to boiler tubes, the shape
on the U bends on heat exchangers for a second. Some customers and some providers will use expensive or sacrificial probes that are one-time use, still very slow and very expensive when they've got to buy a probe that they know is going to be damaged as a result of pushing it around those bends to be able to get the customer some information. So there's limited capability, slow and expensive, versus MachOne that's fast and accurate and is not going to be sacrificial.
That's correct.
That's
the problem.
The problem. Sorry, go ahead.
The problem with those probes, those flexible probes for eddy current and other systems, it's not only that they're sacrificial, that they're very fragile. Any kind of obstacle will damage them. That's a fact. The bigger issue is that they cannot be used for every U-tube. Middle rows cannot be covered by those flexible probes because they are not fully flexible. They have some flexibility, but they cannot cover every shape. So
yeah. Some of the U bends are such a tight bend that they simply can't circumvent across that radius. Yeah, and MachOne can address all of those, from the tightest inner tubes to the wider outer tubes.
Exactly. The reason why I went back to U-tubes is to explain and answer your question about boiler tubes with different jobs.
Yeah. So let's go there, because boiler tubes are not just U-bends, but they're often a variety of different configurations around angles of bend. So how can you handle that, and what can you tell customers about boiler tubes and furnace tubes?
As long as they fit inside our capability range, which is up to 76 millimeter or 3-inch in inner diameter, and as long as they are not longer than 40 meters or 130 feet, we can do it. We can do it easily. So and we have been doing that successfully for a while now.
We've had customers who they're looking for leaks. We've had customers who have had issues where they've had boiler or furnace tube blockages that they couldn't find, couldn't detect, and then had overpressure failures as a result. So it's a pretty serious industry issue. Some of the attempts to inspect this were really expensive and time consuming. Almost like smart pigs that they use in pipeline on a small scale, but I haven't seen anyone do it on a large scale that is cost effective and fast. And so most customers don't have an easy way, and are often not being able to inspect. They get them clean, but they don't often have a way to find the leaks. Tell me about reporting, because reporting times on a turnaround are pretty critical in trying to make decisions. How have you approached speeding up reporting and making it faster and more accurate with what you've been, with your R&D teams, in terms of how you've developed software?
So, speaking about reporting, we have to take into consideration two scenarios. The first one is when analysis and reporting is being done by our experts in our R&D center. The second one is when customer is performing its own self-analysis. So I will cover both options.
Sure.
In case of most of our clients opt for analysis done by Swiss because of experience that we had in the past and millions of tubes that we analyzed. But in the meantime, our software development was constantly progressing, and we started using advanced AI models and machine learning models to speed up analysis process and to make it automated. Eventually, that led to that we can give out that software to our clients and be sure that results that they are getting are as reliable as ours. So the whole analyzing process, when done by Swiss, is very simple. Data is being uploaded to our servers in a couple of different ways, directly from the device, using thumb drives, using additional software on PC. So all options are available. That covers all situations when you have or don't have an internet access in the field. All our final reports are guaranteed to be delivered within 24 hours. But we provide for emergency situations like a leak detection, we provide preliminary reports every hour during the inspection work.
That's faster than having an eddy current analyst on site.
That's true. Yeah. That's not everything. We have also an option for real-time analysis. That's the situation when you have working internet connection in the field, and now expert analysts are remotely connected to the device and performing analysis as data is being collected. So that's basically final report within 1 hour of final tube inspected, right?
So you're using, kind of to summarize it for listeners, with traditional methods, people use different software, but one of the Achilles heels, weaknesses of the variety of inspection methods is it's reliant on manual analysis, subjective in some cases, by experienced to some degree of eddy current, iris, and remote field technicians. But what you're talking about is you've leveraged machine learning and AI to speed up the process to semi-automatic to near-automatic. The MachOne is Wi-Fi connected. You can upload directly to the server from the device, from the computer. Yesterday or the day before, you showed me how you can take a USB-C from the device and plug it directly into an iPhone and then upload it that way if your connection is that way, which I thought was fascinating and faster than anything I've seen. And then you've got preliminary reports that are 24-hour reports if that's what's needed, preliminary reports every hour, or real-time analysis if that's the case in terms of the customer need. I mean, that kind of covers the whole gamut of everything that is a challenge with analysis and reporting with current methods.
Correct. Another thing that we leveraged using AI models and machine learning, and this automated analysis, this has started to be an fully automated process, is to remove subjectivity. You touched on eddy current technicians analyzing and their own interpretation of the what they see. So every technician can have a different interpretation of what they see. That's
the problem. One of the things I've seen with a lot of end user clients is the subjectivity of the capability of eddy current, iris, and remote field technicians doing reporting is such a challenge that most clients who are listening will have some sort of a test bundle at their facility where they have known defects, and they will bring, when electromagnetic tube inspection companies want to get their technicians approved, they've got to get them pre-approved on the customer's test bundle to see if they're able to find and evaluate the defects that the customer knows about. It's the subjectivity and the skill of electromagnetic technician analysis capabilities is such an issue that almost every client out there has some way of pre-evaluating, pre-testing, and pre-approving the technician, because the subjectivity and that capability is so variable. So how have you taken that out of the equation?
Don, the fact is that we had the same issue in the past. Mm-hmm. So we were not different in that regard to existing technologies. We had subjectivity problems with our analysts, so it took us a couple of months to get our analysts up to speed, so they're capable enough to reproduce results that are similar to what others can do. So we were trying to level up all the analysts so they are capable to similar levels. Then we pushed really hard and tried to find a way how to remove that aspect of subjectivity from their work. We started with different solutions in our analyzing software, manual solutions in the beginning. Simple. I'll just mention something as simple as giving exactly the same zoom ratio, aspect ratio to every analyst, so they cannot take a look at something differently than that's something that happens with all other analyzing work. That's the simplest thing that I can mention. But then we went a step further and further. Eventually, we ended up with leveraging machine learning and AI models to do pre-analysis before a human being analyst goes back and do the check, because we cannot remove human beings from analyzing. Although AI models are so advanced now, we have so much data to train those models on, but still you need a human eye. If nothing else, you need a human to be responsible for that report. Someone has to sign off.
But the whole process of those changes, the AI, machine learning automations you built in, makes it more accurate, more reliable, more consistent, and faster.
Oh yeah.
Right.
Again, orders of magnitude faster than it was before.
Right. So the data collection is faster and the reporting is faster, and both are more accurate because of advances in this tech.
Yep.
So not every, you and I have talked about this, and and we talked about the limitations and the capabilities of some of the other tube inspection technologies. Every technology has its strengths, and its limitations. We've talked about leak detection, we've talked about cleanliness, we've talked about blockages, we've talked about speed in data collection, we've talked about speed and automation and reporting. I mean, there's a lot of great stuff there. Talk to me about a lot of other technologies, and customers are also are being used for wall loss. What is your approach related to wall loss today with MachOne?
Yeah, the challenges we are facing with wall loss are wall loss detection. Are a couple of them actually. First of all, we have a hard-coded limitation that's based in physics. That's something we cannot change, and that's that we have no OD detection. So outer diameter, external surface wall loss detection whatsoever. That's based on the fact that we send sound waves down through the air inside the tube. So nothing from outside is detected. So that's a clear limitation.
It's an ID tool for sure.
Yeah. Then there is another challenge with wall loss detection, and that's something that has been a major challenge for a very long time now, and that's the cleanliness level. So it's a bit complicated, and this has to be cleared for our customers and explained that our tool requires different level of cleanliness for different type of defect detection. Right. So to put it simply, the pre-requirement for any kind of work with our tool are the dried tubes. So tubes must be dry, no water inside whatsoever. So that's the first limitation. For blockage or cleanliness assessment, for blockage detection or cleanliness assessment, it's very simple. You don't need any cleaning beside drying tubes, because it's logical. You're trying to assess the cleanliness level, right? For leak detection, on the other hand, we require just the basic air blowing, nothing else. The reason for that is we need all loose particles removed.
Right.
But then we come down to wall losses. Contrary to what I just said, for wall losses, we need a perfectly clean tube, which means for people who are familiar with the topic, iris level clean tubes, down to the bare metal clean tubes. Otherwise, any kind of dirt, dust, scale will interfere with our findings, and we will get either false positives or we will miss something important. So, requirement for wall loss detection and is perfectly clean tube.
Okay, so it's capable, but it's iris level cleanliness. So,
Yeah.
for cleanliness inspection, for blockage inspection, tube needs to be dry. For leak detection, the tube needs to be dry and air blown. And for wall loss detection, same level of cleanliness as customers are used to with iris.
Exactly like that.
Okay, so then
So
if you get iris level cleanliness, what can you tell customers about when you're doing that kind of inspection?
Yeah, so if we get to the cleanliness level needed for successful wall loss detection, we can find wall losses as small in diameter. When I say wall losses, I'm speaking about local pits. So pit in diameter of 3 millimeter, which is actually an improvement compared to the previous systems, which were limited to 5 millimeter in diameter pits, and 20% of wall loss. Actually, the depth of the wall loss. Of course, there is a limitation in terms of how long can we go, where can we detect those wall losses is up to 20 meters instead of 40 meters, which is case for leaks.
So I'm thinking about, again, how this technology can be used to speed up and even using conjunction with other methods that customers. So if a customer's already planning to do iris, say, or even if they've got clean tubes that they are going to do eddy current or other ones on, but they've got the cleanliness there and they're ready to go into electromagnetics. One of the limitations of all of those technologies, eddy current, remote field, and iris, to different degrees, is they're all really slow. And because they're slow, customers are often having to only inspect a sample of the bundle, 10% sample, sometimes less than 10%, cross patterns, trying to get some sense on what's happening. But if they've got a tube bundle that they've cleaned for those technologies, could you use this as a screening tool to then tell the customer where they can then go in and use other technologies to do a true up and maybe qualify? So instead of just having a cross pattern and saying check these 30 tubes, could you use it to inspect all 1,000 tubes and then tell them here are the exact 50 tubes you should look at?
Definitely.
Yeah.
That's one of the options. So since MachOne is so fast, we can screen, in this case, the whole bundle, provide information on which tubes to concentrate, and on top of that, provide information if there is a leak outside of those tubes. So if you're sampling only 10% of the bundle, and there is a leak somewhere where you didn't randomly inspect, that leak will remain there. And when you put that bundle back to service, it will still leak. So this way you're solving a couple of issues at the same time. So you're pointing iris crew where to go and inspect in more details regarding the wall thickness, and providing a full report on leaks at the same time. So
So they're going to get a fast screening to target the iris or eddy current or remote field crews who probably can't find the holes anyway. And we can find the holes and then tell them, instead of this cross pattern or random selection, actually check, these tubes in these rows and these columns. So they are actually using the other technologies for more targeted tube qualification.
True.
That's
Yep.
that's a way better approach than random sampling.
Random is just random, right? So
Yeah. Yeah, it's you're using random sampling to hope you find a trend as opposed to using these other technologies to actually inspect the ones that need to be checked. Now, elephant in the room. I know about them. You know about them. Our listeners, some of our listeners may. There's been other sound-based technologies on the market that promised big things. Maybe didn't always deliver on as much as they were promised. What makes MachOne different?
yeah, the basic physics principle behind our technology is acoustic pulse reflectometry. So that's the physics principle that was used before with a certain level of success. Actually, our previous private label made Sonic 5. We didn't develop Sonic 5. Another company made it according to our requirements. Also had the same issue. They all have root back when the APR was first implemented for industrial use. That was back in 2008. And the type of algorithm chosen at that time, because of different algorithms were not available, or they were not developed enough to be used in industrial setups, had a severe limitations that cannot be overcome. So that algorithm, the problem with it is the sound energy levels that are being pushed inside the tube are not nearly enough to overcome the background noise. So that background noise can come from external noise. We are all aware that in industrial setups, background noise, external noise is ever present. And usually it's significantly higher than anything else you can witness in outside the plants, right? But not only that type of noise, but noise coming from the system, from the device itself, has an influence on the quality of a signal to noise ratio. So the signal is something that you want to get, and you want noise to be as low as possible. The problem with that algorithm is that it's not nearly powerful enough to overcome that background noise. So usually in perfect setups, that signal is barely higher enough so you can differentiate it from background noise. But that's not the real life. In real life, we have much more noise than that. That was limiting those systems in every possible regard. So in range, in detection capability, and in reliability in the end. So the results that we were getting from those systems were influenced by other factors. First place is of course noise. With MachOne, we actually, as I said, we had the same problem with Sonic 5. But since we were not the company that developed it, we decided back in 2018 to start from scratch. We set up our own R&D department. We started investigating, and due to COVID and chip shortages, it took us a while, but now we are here. But in the meantime, we made not only one, but a couple of breakthroughs in regard to the core algorithm that we use to generate those acoustic pulses. The new algorithm that we are using has a couple of very, very important advantages. First of all, it injects up to 4 times more sound energy into the tube compared to the previous algorithm. We are using advanced multi-channel analog to digital converters to reduce noise. We are using next-gen microphones which have a huge dynamic range and very, very low self-noise. The previous systems all used old analog microphones that had a lot of self-inflicted noise. All that combined, but in the first place, the algorithm itself gives us 4 times better signal-to-noise ratio, which allows us to have inspections of only 3 seconds. So the previous algorithm to achieve even similar results, you would need 4 times longer measurements and two times higher volume. The problem with volume is that you cannot increase volume when inspecting tubes because of tubular shape and physics that follow that. So there are limitations that cannot be overcome with the old one, but the new algorithm overcomes that. And on top of that, as a cherry on cake, is that our new algorithm has capability to separate noise, actively separating noise from the signal. So we are getting a very, very clean signal out of our measurements, and that's why we can do it so fast and find even smaller defects and at significantly longer tubes. So up to 40 meters compared to 10 to 15 meters with previous technologies. So yeah, I would say that that progress that we made with the algorithm is the main reason why we can say with confidence that all those troubles that we've witnessed with previous iterations of similar technologies or with existing solutions from other companies that still use
the same approach,
15-year-old algorithm that it's proven not to be capable enough for industrial inspection.
Yeah, well, you and I have been talking about this technology for 6 years, I think, and we own your original Sonic 5 version, and it had issues around. I mean, I remember we did a project where the customer had a compressor running nearby, and that compressor noise just could not be overcome to find things in that tube in that situation because there was so much background noise that you couldn't extract the signal. We were in training this week with our technicians, and I was just blown away that 3 seconds, a small bleep, and instantly you can see the waveform signals on the LED screen. And even for someone who is not yet an analyst, I could quickly look at the screen and go, hole, blockage. I could see. I mean, I wasn't doing the sizing, but you could the signals were so clean and clear and obvious that it was mind blowing for me. Hello?
Yeah. Can you hear me?
I can hear you. I can't see you.
Don't know what's going on. Some technical difficulties.
We'll have to edit this out. Zach, are you around there?
He's not. He's outside.
Hang on a second. I'll call him in. I'll pause the recording on this. Yeah, talking about the quality and the difference between the old technology and the new technology, we've known each other for 6 years plus now. We bought the your original Sonic 5 unit that used the old methodologies and technology. And I remember we were doing an inspection on a furnace, and the customer had a compressor nearby, and the noise of that compressor just overwhelmed the amount of background noise, and we just couldn't overcome getting quality signals out of what that instrument was reading. And then this week, in training our people on MachOne, and we had a known defect heat exchanger that was fabricated with a variety of defects, and it blew my mind that the 16 tubes in that training and evaluation bundle, 3 seconds a tube, beep 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 beep, and instantly on the LED screen we were getting strong, clear signals that were telling us where the holes were, where the defects were, and it was so fast and so obvious just by looking at the signals on the LED screen on the instrument without any analysis whatsoever. Just in displaying the LED screen from the MachOne on to a big screen, we were able to see and find all of these issues, quite frankly, instantaneously. And it was just mind blowing that, and there was an awful lot of, and you and I have talked a lot this week about a lot of the science, a lot of the math, and some of what you were talking about was way over my head in terms of the technical speak. But the gist of it is that you guys have spent 6 years working out every single bug you could think of to get the logarithm right, to create all of the right systems to either identify or remove all the background noises that could impact that signal quality, and that noise to signal ratio, from the analog to digital converters to the next gen microphones. This is a quantum leap forward from what you had before.
Yeah, we would need an additional podcast episode just to talk about those improvements, right?
Yeah. I mean, there's going to be listeners out there who who geek out on technology and will actually understand everything that you were talking about this week. The gist of it for me was you just made an exponential leap in tube inspection technology compared to what existed with that physics principle of APR that existed for the last 10 or 15 years. And all I can say is I'm glad I waited. Right? I'm glad, we were talking about how patient I've been while you've been developing this technology.
Extremely patient.
Come out. And I can tell you what, I'm super impressed. I can't wait to get this out with our clients, both the end user clients and, just to be clear, with inspection contractor clients who are out there who want to work with us as well. This is not a technology that is going to be for one company as a service company. We're going to try to bring this to as many technicians as possible to help as many clients. Before we finish off the episode, you head up the R&D team in Belgrade, and there's lots of details you can't share because of patent applications and proprietary things. But without revealing too much proprietary information, can you give us a sense on what things you're working on, what's going to be coming up in the coming months from Soundwave in relation to MachOne?
Yeah, sure. Our complete effort is laser focused now on AI and machine learning. In actually implementation of AI and machine learning in automated analysis. So we started work on that. We are using that internally, but we want to bring that to our clients as well, so that our clients have capability of self-analysis with all those advanced algorithms and models that we are building. So the next year is the end of this year, and next year we are completely focused on that. And I can predict that by the second half of next year, we are confident in distributing the self-analysis software to our clients as well, so they can leverage our advancements. So yeah, the full focus is currently on AI models and machine learning. But on top of that, of course, the rest of the software and hardware, for that being, is not left aside. So we have a couple of things that I cannot share right now that we are working on, but all those things will just improve usability and detection capabilities of our system. And of course, in the end, that will result in precise reports for our clients and their clients, our clients' clients, when we make this possible. Now, this is possible with our analysis, but we want everyone to be able to do that, even with just one day training. So we are looking forward towards that.
Well, you've told me a lot about what you're working on, and obviously we can't share all of it. All I can say is, folks, it's going to be incredible. I'm super excited. The things that we're going to be able to do with MachOne into 2025 are mind-blowing in terms of all tube inspection technologies. There's a lot of cool things coming, and you know, I think we've already made, you know, light years and leap years of advancement in terms of speed, in terms of capability, in terms of ease of use, in terms of reporting, in terms of accuracy. Already, this technology will make a huge improvement in reliability and in productivity in the field right now. And as Ivan and his team continue with their R&D efforts with AI and machine learning over the coming months, it's going to blow your mind. And I'm super excited. I can't wait to get some of these updates in my hands, some of the software updates that we've talked about. So, Ivan, my friend, fantastic. You know, you've been working on this for 10 years. We've been talking about it for, well, more than 10 years, but 10 years with Soundwave. We've been talking. It feels like a decade, but I guess it's been about 5, 6, 7 years.
Something like that. Yeah.
And for our listeners, just to be clear, this is not. These tools are here on the ground in Edmonton, ready to deploy right now. As a matter of fact, that's actually incorrect, because there's one in Edmonton and there's one already heading up the highway to Fort McMurray today. And so this technology is boots on the ground, technicians trained this week, capable of doing tube inspection right now to do data collection and be able to upload and start doing reporting for you tomorrow. We're recording this, and we waited to record this until we were ready to actually provide the solution to customers, and it's ready. And we're excited to start helping customers and to partner with other inspection companies to help augment and enhance what they're doing as well. So this MachOne is going to be for everyone, and we're going to be here to help both end user customers and other inspection companies alike with our partner Soundwave. Ivan, I'm been a long time waiting for this, my friend, but I'm super excited that we're here. Thanks so much for coming on the podcast and sharing about this.
Thank you, Don, and thank you for the opportunity to share our work and innovations that we came up with.
Now let's go inspect 1 million tubes here in Canada.
Yeah.
All right.
Yep.
There you have it, folks. Soundwave inspection, MachOne, the most advanced, fastest tube inspection technology that you've ever seen. And I'm just going to tell you myself, it's 3 seconds. That's not an estimate. It literally goes beep when it's done, and it's 3 seconds long, and you've collected the data on the tube. I've done it myself, and I'm not that smart. So fantastic. Thank you very much, Ivan. And we'll catch you on the next episode, everyone. Thanks for listening. Bye for now.
Cheers.